Okay, good morning, everyone. Thank you, Cole, for your introduction, and thank you to the MLA for having me. I'm very excited to be here and talk to you about the way that we approach innovation. And of course, we do approach it from a material perspective. So we definitely appreciate the way that materials can be used to inspire design and also to solve a number of problems. As Cole mentioned, we are a global innovation materials library. We have a number of offices around the world. We started about 17 years ago, and currently there's over 7,000 materials in our library. All of them are commercially available, and they need to be innovative in some way, and there's a number of ways that we categorize that. Our members come from a number of different industries, so footwear, cosmetics, packaging, apparel, and we really use that to inform some of the solutions that we recommend. So one of the ways that we approach innovation is looking at ideas and the way that we can use cross-pollination to inform them. So what we mean by that is when we look outside of our industry and learn from them. So I have a number of examples that you might find interesting that have been quite successful. So Nike is one of our members, and they found in our library a material which was designed for housing cables and wires. So it's a braided mesh. And what they did is then go to the manufacturer and say, we want you to do this with our material. Can you do it? So thankfully, the manufacturer was up for it, and they braided this tube a lot wider and flattened it. And then it was used in the Air Jordan shoe, which you see here, and it was one of the top-selling shoes of its time. Aveda, also one of our members, they wanted to find a material which was going to represent their brand. So they wanted something which was natural looking, but which could be used with their current processes. So we ended up recommending a patio material that's made from a wood and plastic composite. Cerakote is a ceramic coating which was developed for the gun industry. And you can see an application here in a consumer product as a watch. So the advantages here, or what the designers did, was look at the properties that they desired and then find something that was going to match it. So this coating has very high hardness and abrasion resistance. This one is an example of the way that materials can be used to inspire the design rather than be directly applicable. So you can see the image on the right is a sail, which probably many of you are familiar with, which is reinforced. So it has fibers which run in particular directions based on the forces that are going to be applied to it. So what Nike did with this idea is then use that same I guess, process to design this shoe. So you can see the red threads that are running on your right are only in particular areas where you need that strength. So cross-pollination is definitely something that we believe, Material Connection anyway, will inspire new design and help people innovate. The other thing I want to talk to you about today is the way that you can use materials to solve some of your problems. And these categories that we have here are ideas or things that many different industries are trying to solve. So lighter, renewable, flexible, interactive. And we're going to show you a number of different materials which fit under those categories. Not all of them may be directly applicable, but we're hoping that you'll find them inspiring in some way. Okay, so lighter. Again, many different industries are wanting to do this, whether it's consumer electronics, footwear, apparel, motorsports. The desire to go lighter obviously has reductions or has advantages in terms of reducing weight, reducing cost, and the way that the consumer can interact with the product. That can be achieved not only in the materials that are chosen, but also in the processes that could be used to create these products. And the Nike Flyknit is a great example of that. This is for those of you that aren't familiar, it's a combination of weaving and knitting processes that are used to create 3D structures. So this shoe is one of the lightest on the market, and it has completely eliminated a lot of the cut and sew processes that were used in traditional footwear. Okay, in terms of materials, obviously composites are used a lot in a variety of different industries. And one that we've recently seen come through is Amplitex Power Ribs, which is basically a structure made of flax yarns, which are cross-laid for strength and then secured with a polyester yarn. The advantages of this type of material is you're able to produce composites which are much lighter in weight, but with the equivalent strength of other materials. So it's designed to be used as an alternative to glass and carbon fiber. And flax is obviously a renewable fiber, so it grows very, very quickly versus other materials which take a lot more processing. The other advantage of flax is that it's a hollow fiber, so it has very good dampening properties, so it absorbs shock quite well. Okay, Sorak, again, another material which is designed to make lighter weight composites. This has a really interesting visual as well. It basically looks like honeycomb with a variety of different hexagonal chambers which contain materials that don't want to absorb any resin. Then the channels that run between those hexagons control the flow of the resin. So again, you're able to produce really, really lightweight composite structures, which also look quite visually interesting. And this material has found application in wind farms and things like that. Okay, Sauna Board. Again, this doesn't look like much, but the story behind this material is what's exciting about it. So it's actually a foamed polyurethane that contains glass fibers. I'm really excited about this material for a number of reasons. It was intended as a replacement for plywood. So we all know you wet plywood or you wet any wood and it's going to swell. So this is being used for concrete formwork because it doesn't swell, and you can also fix any holes that appear in it. So although it's more expensive to start with originally, you're able to reuse it constantly. The other good thing about this material is that they've found that it's a really good insulator as well. So it's actually the material that they use to cover ice rinks when you want to convert it to a concert space or something else like that. It is quite light, and it does have very, very high strength-to-weight ratio in comparison to plywood. Excuse me. 3-mesh, again, another material which I love. So we've all seen spacer textiles before. They've been around for a while. They're in our sneakers, they're in our backpacks, they're in a lot of cushioning type applications, and also in applications where you want to have breathability, so against your body. What we've seen, some of the innovations in terms of these materials, is they previously had a lot of trouble with shearing. So when you increase the thickness, they tended to flatten themselves. So what they've been able to do here is control the way that those middle yarns are spaced so that there's no shearing, and also you can control the levels of firmness amongst within the one material. So this is starting to, again, find a lot of applications in automotive upholstery, in mattresses, and things like that. Okay, renewable. Again, there's been a lot of talk about renewable and sustainable materials, almost to the point of exhaustion, and some of it can be very confusing. But what industries are finding, including the automotive industry, particularly in Europe, is that the government is starting to mandate the types of materials that they can use and what's going to happen to those materials after the end of the product. So we're seeing a lot of innovation here, things like bamboo, the use of renewable materials, the use of biopolymers as well. So that is creating plastics from natural precursors rather than synthetics. And we have some materials that we're pretty excited about from our library. Salmon leather. So it sounds weird, but it is normally a waste product of any fishing industry. And what this company or this manufacturer has been able to do is find a way to process it so that it's washable, first of all, and that it can be used in a number of products. So you can see, again, another footwear example here, but it is finding application in upholstery as well. One of the really cool things about salmon leather, which I certainly didn't know before I found this, was that normal cow leather has a grain in one direction. Salmon leather has a cross grain because of the scale structure. So what you find with this type of material is its strength is much greater when you compare a similar cow leather of the same thickness. So that cross structure really influences the strength of this material. Thanks, Caroline. Okay, Ecovative. This is a material which basically was started by a bunch of students in their basement. And what they did is get agricultural waste and spray it with mushroom spores so that they could grow a packaging material which was cushioning and completely compostable. What's really cool about this material too is that you can mold it, so you can grow it over a shape, and then it can be used to package any type of three-dimensional product. Really great story and completely compostable, so you can throw this in your garden at home. Thanks. Okay, another one here is more a process for treating wood. So we know that there's plenty of softwoods that we can get that have a chemical coating on the outside or some kind of treatment to make it more dimensionally stable or durable. What this process has done is using a natural material, so in this case a sugar alcohol, to penetrate the wood. During the curing process, that alcohol then bonds to the molecules of the wood, causing it to not be able to accept water. This particular material is designed for applications where it's going to come into contact with water. So things like docks, patios, outside areas. And the real, I guess, green story here is that you can use rapidly renewable woods versus hardwoods, which we know take longer to grow. Thank you. Okay, the idea of interactivity. So we're seeing this a lot where products that we use, or even services like Google, start to predict our behavior, which can be good and bad, but we're also interested in the way that materials can speak to us after, or products can speak to us after we've purchased them. So a great example of this is the use of thermochromic inks. So Coors Light is doing it where they use color to indicate the coldness or the temperature of the beverage. There's a number of materials or products that are using this same technology. So basically thermochromic inks mean that they react to temperature. So when you heat it or when you cool it, the material will change. So I'm just going to use friction to generate some heat here. And our material changes from maroon to bright green. So what's actually happening here, is that top layer is becoming clear, so revealing what's underneath. The interesting thing about this material is it's actually a two-phase, so you can then cool it and it will go black. Again, there's a lot of potential here to communicate with your consumer after they've taken the product home. So to put some kind of hidden message or some interesting fact in the material that then they can be revealed to them later. And it's certainly a way to, I guess, to get around the traditional modes of advertising. This material here has a lot to do with the interplay of light and the way that a material can move once you view it from different angles. So it doesn't look like much from here. But when you hold it up to the light, which you'll do as it goes around, it contains glass fibers, so the light actually passes through the material. Again, there's a number of these types of materials that we're seeing. We've seen applications in concrete, in wood, as well as materials which have an interplay, so a clear material connects through it, and you can basically pass light on it, and you'll get an interaction there. So again, the way that the material can interact with you. This material very much uses the idea of texture. So you want to physically touch it, you want to play with it, or you want to feel it in some way. It's called a decanel panel. So it's a decorative wall panel which uses textiles and foam to create this dimension. One of the other things that they're doing is incorporating crystals or LEDs within the material, which light up. So as this is passed around, if you put your cell phone's flashlight in the tube at the back, you'll see this panel light up. And it's quite, the girls love it, the ladies love it, particular. Okay, flexibility. Again, a property that's becoming much more important, particularly in the consumer electronics industry. So there's definitely a race to see who can produce the first flexible phone. The Consumer Electronics Show in Vegas had some great examples, but it's just trying to figure out how to do it on a commercial scale. A lot of products that we buy now also take advantage of this property and are introducing materials which will allow it to flex and to be a little bit more durable. So particularly the Ray-Ban sunglasses that you see on the right, they've been made from a new material which flexes, so you can bend those side bits. You can bend those bits without breaking, which has a lot of advantages. Okay, Softgel. This is another material which was developed for a particular application, but has found others which are also relevant. So it's something that there's definitely a lot of people in our office who like to touch this, and usually when people come into the library, it's one of the first ones that they gravitate towards. It's a gel or a liquid-like material that's held within a thin plastic film, but it has the other properties of a solid. So it's very dimensionally stable, and it wants to keep returning to its original shape. It has been used in applications like shoe insoles, and it does also find application in cushioning devices. It'd be great to have it as a mattress, but it is quite heavy, so that's a problem that we need help with if you have any ideas. Shape-retaining plastic. This is a really great example of cross-pollination as well. It's a material that was developed for a specific application. It's out of Japan. So there's a lot of these types of protective masks used by everyone just walking around. The problem that they had is that the traditional metal clip that's used to attach it to your nose made this whole thing not readily recyclable. So a company in Japan developed this material which is called shape-retaining plastic, which has the moldability of metal. So you can see right now, I'm just bending it and it's staying. So as it goes around, you can see that it's made of a number of different layers of this plastic. Excuse me. That's cross-laid, which gives the material the ability to deform and to stay. This material has now found application in protective shin guards, in elbow, in a number of different applications where you need it to bend around your body. Okay, metallic textiles, again another one which appeals visually. So it's a textile that contains metallic yarns. What you're able to do with this is then form it and shape it so that it will hold in particular ways. Again, this was designed for interiors and upholstery uses, but it does have some properties related to the metallic yarns as well in terms of shielding or static discharge, things like that. Okay, the idea of protective materials. Again, this very much has to do with the types of materials that are being developed, as well as a number of different applications. So the example that you see on your left is a new impact-resistant material that was specifically designed for helmets. And it's actually made of a number of different polycarbonate straws that are laid together and then fused. So you create this honeycomb type material that has incredibly high impact resistance. And it is being used for helmets and things like that. The other applications you see there have a lot to do with innovations in the materials. So stronger plastics, thinner materials, lighter weight, that still provide the amount of protection that's desired. Again, this is another one that people love. It's called Ceraspace. And what it is a textile that has hundreds of little ceramic particles printed onto its surface. It was designed for, for the motorsport industry. So thankfully I've never experienced, but when a motorcyclist skids, there's quite a lot of friction created there. So they needed materials which had very high abrasion resistance. What's traditionally used as leather, but one of the problems with that is it's a flat material. So it starts to heat up, and you can get a lot of damage just by the heat of the material. So this material, with their tiny little ceramic spheres, creates an air chamber around, which doesn't cause the material to heat up. So not only has it incredibly high abrasion resistance, but you're able to control the amount of heat that's generated from that skidding motion. Okay, muchrome. This is a process for coating aluminum profiles with chrome. The innovation here is that it's not done with a galvanizing process, it's done with a vapor deposition process. The other thing that this manufacturer has been able to do is do very long profiles, so 2.4 meters, about 8 feet long. And the other advantage too is that they've been able to bend it and form it after it's been coated with the chrome. So again, it's finding a number of different applications as well as the traditional ones, but this is a great example of the way that we can use processes to innovate, not just materials. This material is called Skydex, and it was actually developed for NFL helmets. And they've done a number of tests on this. When you see it, it's actually a series of cups of plastic placed opposing each other. So you push down on them, and these cups, I guess, absorb the force. What's really interesting about this is the way that you're able to modify the shape and the density of those cups throughout the whole material. So it doesn't have to be uniform across the whole structure. Again, this was designed for a very specific application, but it's starting to inspire a number of other industries as well. So particularly the mattress industry and the furniture industry is very interested in this material. Okay, water repellency. It seems like everything needs to be water repellent now, which has advantages for us. We've definitely seen the way that nature can inspire this. So the idea of a lotus leaf, that kind of idea has been used by companies like Avon to create cosmetics which act in a similar way. The visual of seeing liquid bead up on something is very appealing. The image is in the center, the Logitech Fabric Skin keyboard folio. So that's a case for an iPad, which actually uses textiles instead of the traditional plastics. And this is actually a project that we worked on with them. But one of the great things about this is the materials used were taken from outside of their industry. So the inside fabric is a footwear material. The process used to apply those keys is a process from the footwear industry, and the outer materials are from the upholstery industry. So again, a great way that they've looked outside of their industry for a material solution. Okay, I have some great demos now, which I love. Okay, so this first material doesn't look like much, and I certainly was not impressed when I first saw it. But again, the story behind it is what's really cool. So it is a plain woven fabric, but it's made from polypropylene. So we all know polypropylene, very, very cheap plastic, but one of its advantages as a fiber is it is extremely light. Lighter than any natural, even lighter than polyester. And polypropylene is the fiber that's used in a lot of those shopping bags that you get for free. And so it's used as a non-woven in that application. And it's also the material that's used in IKEA bags, so that very thin woven tape, and also in sacks to contain rice, things like that. This is one of the first applications as an apparel fabric. So it's very, very light, very, very soft. The other advantage of it is that polypropylene is inherently water repellent. So you drip water on this and it rolls straight off. There is no coating on this, but the polypropylene itself is just getting that water off straight away. So again, something that we really, really excited about. Again, it was designed for board shorts, but it could have other applications as well. P2I is a water repellency coating, but the way that it's applied is quite novel. So it's also applied by plasma deposition. So that is taking a gas and applying it to something as a solid. What's really cool about P2I is that you're able to penetrate every single surface or component of a product. So this is the process that's being used to waterproof your electronic devices. So they can put your mobile phone in this chamber, apply the plasma to it, and that'll infiltrate every single section of your phone, including the circuitry. It does contain fluorochemicals, which is not the great part about it, but it does render things completely waterproof. So this is a normal tissue. I'm going to dip it in the water, and it does what you expect. Okay, so it gets wet and a bit messy. This is a tissue that's treated with P2I. So again, I dip it in, and nothing happens. So it is completely water repellent. Yeah, go for it. So again, one of our favorite materials at the moment. Okay, Ultra Everdry, another water repellent coating, but one that can be applied to ceramic, to wood, to metal, to glass, to leather. The advantage of this coating is it is a spray coating, and also it doesn't contain fluorochemicals. This is the, oh, you took my water. It's okay. This is the material that was seen in the TED Talk, where they threw paint on the wall, and it basically revealed Ultra Everdry. You can literally see, sorry Ritz, you can see those water beads just roll off this. Yeah, so again, a really interesting material that has also shown an improvement in process. So the use of fluorochemicals is problematic, and some people don't want that either. So this is a great example of an improvement there. Printable. The idea of printing our products, it has been referred to as the next industrial revolution. I'm sure a number of you already use this process to produce your prototypes of products, but what we're seeing now is improvements in those processes where you can actually produce the components rather than just prototype them. So the image in the middle is a jet engine where they're actually printing that cone on the end. Same as the Nike shoe in the middle. That's their Vapor Laser Talon, which is a spike shoe intended for soccer and running applications, and the sole of that is 3D printed. So you can customize it to the individual. 3D printing is also being used to produce medical implants, and also for decorative purposes as well, so fashion, prosthetics. We have some examples today of new additive manufacturing processes. So this one in particular is by Objet. What they've done here is they've been able to print multiple materials at the same time. So you can print elastomers, you can print PCABS, you can print a number of different things. This hand is kind of freaky, but it's definitely a great example of the way that two different materials have been used. Electron beam melting. So this is an additive manufacturing process for producing metallic parts. And we've seen sintering used before, particularly for stainless steel. But the innovation here is the ability to produce these parts from titanium. So we know that titanium, again, is a very strong metal for its weight. So they've been able to produce these really intricate structures by building up layers of metallic powder, which they then fuse together. So particularly in this example, you can see very, very fine detail and structure. The surface finish is not as smooth yet as it could be, so it does need post-finishing, but again, you can get these really, really intricate structures. Okay. And lastly, this is one of the newest things we've seen, which got a lot of people excited. It's a 3D printed part that has elasticity and flexibility. So what they've been able to do is produce an elastomeric powder that they then lay down in layers and sinter and fuse together. This hasn't really found any application yet, but it is certainly one of the most interesting things that we've seen in 3D printing. The real developments in 3D printing are coming in terms of the materials that they're able to print. We do have a material in our library as well, which is a wood polymer composite that they can then print. And again, this one is one of the newest as well. Okay, so I've shown you a number of materials which I hope you found inspirational in some way, and I hope that you've seen the way that materials can be used not only to solve your problems but also to inspire the design.